up everybody, I'm Manasa and I'm your computer science tutor. Alright, so before we start anything, I want you to try two things. Number one, chapatlu kottandi. You done? Number two, dikkulu chudandi. Yeah, I know y'all are like, what the heck is she doing? Well, that's exactly how a computer feels when you tell it to do anything other than binary. Welcome back to my channel, everyone. Today I'm going to talk about computer interface languages, otherwise known as programming languages. Alright, so think about this. When you're trying to learn a new language, you have to know about its alphabet, grammar, punctuation, and a whole bunch of other things. And that's the human interface language because it's humans interacting with each other.
Those racist bastards.
A computer interface language is used for the user to interact with its computer. You know, one of the first computers ever made looked something like this. As you can see, they just had a whole bunch of on and off buttons. Binary. So it was extremely error prone and very tedious to work with.
Which is why they created higher level programming languages. These high level languages are only understood by humans, and the interpreter translates these commands into low-level languages or binary, which only machines can understand. One of the first high-level languages to be created was C, and based off of C, they created Java, C++, Python, C#, and Ruby. And based on Java, they created multiple versions, such as version 1, version 2, and so on and so forth. And based on C++, they created Visual C++, and then .NET. Now, all these programming languages have some basic concepts that you need to know. Number 1, programming environment, otherwise known as integrated development environment. That's where you write, debug, translate, run, and document your program. Number 2, basic syntax. Basic syntax is a set of words and symbols that have a meaning in the programming environment of a specific language. Every language has its own syntax. Keywords. Keywords are the vocabulary of a programming language. Every programming language has a set of keywords which can be used to construct a program. Number 4, operations. That's the math that's involved in a program. They include logical operators, arithmetic operators, and Boolean operators. Number 5, loops. Loops are the repetitive actions that are part of the program. Number 6, conditionals. That's the decision making of a program. So based on the situation, it does a specific action. And finally, file I/O, otherwise known as input and output. Input is the information that is put into a system, and output is the information that is given out by the system.
Now these languages have their own translators that change the commands into binary code. And there's 3 types of numerical systems that you need to know: binary, hexadecimal, and decimal. Let's take a look at them.
Alright, so let's start with the decimal number system. You guys already know that the decimal number system is of base 10, and it includes numbers 0 to 9. Binary numerical system is of base 2, and it only consists of numbers 0 and 1. Machines can only understand this binary code because 1 represents on and 0 represents off. So let's try to convert a binary number into a decimal number. So when dealing with binary numbers, think of them as bits of data. So in this example, you have 6 bits of data, and wherever you see 1, that means you're turning on that button, and each button represents a number that is equal to 2 to the power of the number of bits minus 1. So here you have 100101, and you can see that you have to multiply the binary numbers with 2 to some powers. And then at the end, you have to add everything up. So in this example, you can see that you have to add everything up and you get 37. So that means 1001 101 in binary code is equivalent to 37 in decimal numerical system. Now, let's try to convert a decimal to a binary number. So first, you gotta divide the number by 2. Once you do that, you will get a remainder and a quotient of either 1 or 0. Then, you gotta divide the quotient with 2 again, and you'll get another remainder. And you keep dividing the quotient by 2 and you'll keep getting a remainder until the quotient becomes 0. Once it's 0, you gotta write down all the remainders you got in reverse. And there, you just converted a decimal number to a binary number. You can see in this example where we converted 17 into binary number of 10001. Now, for the hexadecimal. So the hexadecimal is of base 16, and it includes numbers 1 to 9 and letters A to F representing numbers 10 to 15 respectively. It's mostly used for representing colors or to describe locations in the computer memory. Now, let's try to convert a hexadecimal number to a decimal number. Step 1. Write down the hex number with some space in between. Step 2. If it has letters, write the number that they represent underneath. Step 3. Write out 16 to the power of the position number starting with 0. Step 4. Multiply the numbers in the hex number with 16 to the power of the position. Finally, add everything together to get the decimal number. In this example, you can see that 2A5 is converted to a decimal number of 677. Now, let's try to convert a decimal number to a hexadecimal number. Use the same process as you did when converting a decimal to a binary number. You gotta first divide the number by 16. Once you do that, you'll get a remainder and a quotient. Then you divide the quotient with 16 again, and you'll get another remainder. And you keep dividing the quotient by 16 and you'll keep getting a remainder until the quotient becomes 0. Once it's 0, you gotta write down all the remainders you got in reverse. Then you replace the numbers with the letters that represent them. And that's it. You got your hex number. So if you look at this example, you can see that they first divided 699 by 16. And they kept dividing the quotients. At the end, they write out the remainders in reverse and replace the numbers with letters. So at the end, 699 in decimal number system is equal to 2BB in hexadecimal number system. Now, I do recommend that you practice these conversions because you will see them a lot, not particularly in this channel, but maybe for a class or for, just general knowledge. So go ahead and pause this video and try to solve these problems. Alright, here are the answers.
Well, I hope this video helped you understand the basic concepts of programming languages and the numerical systems. Please like and share this video and subscribe to my channel for more content. Mara video lo malikalutang. I'll see you in the next session.